What's up, math fans? Hopefully you know some background knowledge already. I'm gonna give you two hints. You need to know what a chord is, and you need to know the Pythagorean theorem. And it's interesting because when you learn the Pythagorean theorem, you should have learned it for right triangles. So what does it have to do with today's lesson on circles? Well, you'll see. So here, our lesson is a chord, funny looking symbol here, to a radius. The funny looking symbol is exactly what it is. It's perpendicular, meaning the chord is perpendicular to the radius. For example, here's my diagram where I have a circle. We call it circle O. You name it from the center. So circle O has a radius. A radius is from O to C. But look at that chord in blue, AB. AB is a chord. It's a line segment that goes from one point on a circle to another point on a circle, not necessarily through the center. And I am telling you, and they have to tell you this in the problem, that the chord is perpendicular to the radius. So that is a right angle. And that's your hint on what I said a minute ago. If it's not perpendicular, for example, I could have drawn AB at an angle like this, some kind of diagonal. If it's not perpendicular, then nothing I say is relevant. It's only relevant if the chord is perpendicular to the radius. So when it is perpendicular, you have a right angle, and then you use your whole list of knowledge on what you do with right angles. So here's just some notation. AB is perpendicular to segment OC. Once it's perpendicular, you can conclude that AM is congruent to BM. Only if the chord is perpendicular to the radius bisects the chord. So this chord gets cut in half. This piece is congruent to this piece. So if AB was 10, AM would be, that's right, 5. If AB was 50, AM would be 25. If AM was 7, AB would be twice that, 14. So half, double, double, half. All right? If AB was 7, AM would be half of that, which is what? 3.5? Don't be scared of decimals. All right, so and this is only true again if they are perpendicular. All right, here's an example. I'm giving you a circle. I'm giving you CD is a diameter, goes through the center, and AB, I am telling you, is perpendicular to the diameter. But you just said it has to be perpendicular to the radius. Guess what? If I ignore the CO part of that shape, OD is the radius, and AB is perpendicular to OD. So it still holds true. If it's perpendicular to the diameter, it's definitely perpendicular to the radius. So what did we just learn? Let's see. CD is 10. So from here to here is 10. That's a diameter. Guess what the radius is? 5. Radius is half of the diameter. AB is 8. AB is 8. But what did we just learn? If this is perpendicular to this, then I bisected the chord. The chord got bisected. So if the whole chord AB is 8, then I guess this piece from A to M has to be 4. Okay, you got 4 for A to M and 4 for B to M. Also, if you have 5 from O to C, you also have 5 from O to D. And that's important. So now if you're saying find OM, here's O, here's M, from here to here. People are looking at it, if you look at it quickly, and if it's not drawn well, if it's not drawn to scale, you might see it quickly and say, oh, that's in the middle. If this is 5, then I guess that's half of 5 is 2.5 and I'm done. No. I never said that the radius got bisected. I only said that the chord got bisected. So you actually have to do math here. And here's the trick that you have to recognize. If OC is 5, OC is a radius, OD is 5. OC and OD is 5. But guess what? A radius can spin around like the hand on a clock. So this radius can go anywhere. There's a radius, there's another radius, there's a radius, there's a radius. Guess what? If I connect O to A, that's a radius. If I connect O to B, that's a radius. So if OC is 5, that means OA is 5. So I'm going to put a 5 here. And guess what I found? You guessed it. This guy right here, and I'll draw it again for you. A, M, O. I found a right triangle. I know my hypotenuse is 5. I know my height is 4 because it was half. All right, I'll show my work if you want. AM equals 1/2 of 8, which is 4. That's where I got my 4 from. And now you're asking me to find OM. Well, I'll call OM X, and then we'll find the base that way. So let's see. How do I find the missing side in a right triangle? Pythagorean theorem. A squared plus B squared equals C squared. Little a is the base in my question, and little b is going to be the height, or vice versa, it doesn't really matter. So x squared plus 4 squared equals 5 squared. X squared plus 16 equals 25. I do my additive inverse. X squared equals, what is that, 9? Am I done? Is it 9? No. Square root on both sides. X equals 3. Therefore, OM equals 3. And it's as simple as that. It's not as simple as just looking. You can't always just look because it's not always half. You got to be careful. Do what you know. You knew the Pythagorean theorem. Guess what? Thought it was a circle problem. It's actually a triangle problem. All right. Thanks for watching. See ya.